Hi, this is Dave Chapman from J&J Automation in the UK. This short video is to demonstrate the features of our ETL, our electronic torque limiter, which is a standard feature in the J3 range of electric valve actuators manufactured by J&J. Conventionally, electric actuators have over-torque protection by means of a bimetallic strip within the motor windings, so that as a valve is jammed or is frozen and the actuator tries to work against it, the current dramatically rises and the windings in the motor get hot. As they reach a certain temperature, this bimetallic switch will cut the power to the motor, thereby preventing it causing mechanical damage to the gearbox. J&J do it slightly differently. We actually monitor and measure the current that the motor is drawing, and then we have algorithms that will monitor the rate of increase of the current and the maximum current against set points, and if they're exceeded, then the current or the power to the actuator is automatically cut. The main advantage of this system is that it's a torque related system, because the amount of current that's drawn in the motor directly relates to the amount of torque that the actuator is producing. In our view, the other operation with a bimetallic strip is a thermostatic cutout as opposed to a torque cutout. So the way the system works is that, as I say, it monitors the motor current continuously, and if it sees that the rate of increase of current in the motor is beyond that it is expected or written within the parameters, then the power will be cut. Let me just show you the operation here within a three-piece stainless steel ball valve. We have an open signal applied, so the actuator is opening the ball valve. The LED light is solidly lit, and we're going to simulate a jam by putting a screwdriver inside the valve. So if we now send the actuator to the closed position, it'll reach the point where it can't travel any further. There's an automatic gear relaxing system that backs off the actuator, and then we have a flashing light, a continuous flashing light that advises there's a problem with the actuator, and the fact that it's blinking on off tells us that it's the torque limiter that's activated. Now, of course, if this valve was in the pipeline, you wouldn't be able to see that it was jammed because you can't see the screwdriver sticking out of it. But what the operator can see immediately is that the LED light is flashing on-off, and an on-off flash tells him that the valve is jammed. In the traditional system, where you have a bimetallic strip and it's a thermostatic switch, what's happened now in conventional motors or in conventional actuators is that the motor is now hot. It can't operate, it can't run, because it has to cool before that bimetallic strip moves back to allow power to flow to the motor. That's not the case with us, because we're controlling the current and the motor doesn't get hot. So we can immediately send it a reversing signal. The light will go solid because there's no valve jam in this direction, and the valve will open. And the advantage of this is that we can then try and use the flowing media to flush out whatever is causing the blockage in the valve. Most of the blockages will be going towards the closed position. So again, we can run it into this valve jam, into the screwdriver, and exactly the same will happen again. It'll measure the load, it'll take it back a few degrees to relax the gearbox, so if you wanted to use the manual override you could. The light starts to flash and advises, but immediately we can try and flush it out again. So this system of an electronic method, whereby we're measuring the current, has a huge advantage over the conventional thermostatic or temperature related cutout that you see in most conventional systems. Now, if we aren't able to succeed in flushing through the blockage by opening and closing it several times, then the plant may have to be drained and identify exactly what the cause of the increase in torque in the valve is. But at least it gives us an opportunity. A, we can identify very easily, because of the LED light, which actuator is affected. Secondly, we know why it's affected because of the sequence of the flashing. It tells us that the torque limiter is activated. Normally that means that the valve is jammed. It could be another fault with the valve itself. And thirdly, we have the opportunity to actually stroke the valve forward and backwards to try to use the flowing media to clear the blockage. This electronic torque limiter facility is a standard feature within all the J3 electric actuators, as is the LED status light. We find that this level of protection within the actuator is very much appreciated by our customers, and since we introduced the LED status light, the customers love that facility too, because they can see at a glance which actuator is affected. So that's a brief video on the electronic torque limiter, or the ETL, that is a standard feature on the J3 electric actuator manufactured by J&J. Thank you.